Good morning to all. In our previous class, we have touched upon the trigonometric values, trigonometric ratios and the complementary angles. Today in our session, we will start the trigonometric identities. Identities in particular in algebra, we have so many identities. One basic identity we are going to learn, we'll be using normally is a plus b whole square, that is equal to a square plus b square plus 2ab. So in trigonometry, the identities, the equations which are using the identities involving the trigonometric ratios of a particular angle is called a trigonometric identity. In general, we have three identities in trigonometry. We'll see the identities. Sin square theta plus cos square theta equals to 1. This is the first identity in trigonometry. The second one is 1 plus tan square theta equals secant square theta. The third one is 1 plus cot square theta equal to cosecant square theta. So these are the main identities which we are using in trigonometry to solve the problems of trigonometry. So from the first identity, we can deduce two more equations. Like if I take cos square theta, we will send the sin square theta to the other side of the equation, 1 minus sin square theta. And if we want sin square theta in particular, from this identity, you will send this cos square to the other side, 1 minus cos square theta. Sin square theta is equal to 1 minus cos square theta. So from one identity, I have deduced two more equations. We are going to use all this in solving our problems. So next we'll see the second identity. 1 plus tan square is equal to secant square. From this, I'll deduce few more. Just I want tan square theta. That means plus 1, we'll send it to the other side of the equation. It becomes secant square theta minus 1. And another one, secant square theta minus tan square theta equals 1. See, secant tan square, we'll send it to the other side. It becomes minus tan square. So from the second identity, we got two more equations. The same way, we'll get two more equations for the third identity. Now, cot square theta equal to, I'll send this one to the other side, cosecant square theta minus 1. And cosecant square theta minus cot square theta equals to 1. So, all these identities as well as the deduced equations, we'll make use of them in our exercise. So let us see the exercise problems in 11.4. Evaluate secant square theta minus 1, cosecant square theta minus 1. This is a problem in 11.4 exercise. So seeing this problem, we can clearly see that here there is secant square, here it is cosecant square. We have to remind our identities. The second identity is involving the secant square. So I will make use of it. 1 plus tan square theta equal to secant square theta. So secant square theta is there in the second identity. So if I send this to the other side, it becomes the deduced equation secant square theta minus 1. So instead of secant square theta minus 1, I will substitute tan square here. That means we are making use of the identity here in our problem. Same as the cosecant square. For the cosecant square, we will take the third identity involving cosecant square. So cot square theta equal to cosecant square theta minus 1. Here, cot square theta, simply I'll write. I am substituting this in place of cot square theta. Here when we look at these two, These two, as we have told in our previous class, they are the reciprocal to each other. Tan square theta, cot square, I can write it as 1 by tan square theta. So you cancel it vertically. It comes to 1. Now we evaluated this problem to 1 using the identities. This is one problem in the textbook, and let us go for the other problem. Of the textbook. Show that 1 minus tan square A by cot square A minus 1 equals tan square A. So this is show that problem. It is having LHS and RHS. Let me take the LHS part. 1 minus tan square A by cot square A minus 1. Here, all the three identities, we have the second identity as 1 plus tan square theta. Here it is 1 minus tan square and also cot square minus 1. So here we are not going to use the identities, but simply I'll change the tan function and the cot function into sine cos functions. Tan square is sine square A by cos square A. Again, here cot square means cos square A by sine square minus 1. Now we will do the LCM upper part and the down part. If we take the LCM, here 1 and cos square A, 1 cos square A minus cos square, 1's cos square, so 1 should be multiplied to sine square, so it becomes sine square A. Now the down part, we can take LCM as sine square A. Now sine square 1's, so cos square A minus 1 sine square A. This is the LCM part. Here the numerators are same, so we'll cancel the numerators. Here we get cos square by sine square. I'll do it here. The sine square comes to the top, sine square A by cos square A. This is nothing but the tan square A. This is our LHS. Now we have taken the LHS, we got the RHS. So hence proved LHS equals to RHS. So here, seeing the problem, I haven't used the identity, but I have made use of the ratios. That means tan formula and cot formula, and deduce the problem. Likewise, we can do few more problems in the exercise. Let us take one more problem. Here there is another problem from the textbook. 11.4 exercise. Cosecant theta plus cot theta equal to k. Prove that cos theta is equal to k square minus 1 by k square plus 1. So let us take the RHS part, because the k value is given where we have to substitute it. So we'll take the RHS part first. K square minus 1 by k square plus 1. So I'll substitute k value here. K is cosecant theta plus cot theta whole square minus 1 by cosecant theta plus cot theta whole square plus 1. Simply I have substituted the value of k here. Now, if we expand this, this is looking in the form of an identity, algebraic identity, a plus b whole square. I'll take a as cosecant theta, b as cot theta. I'll expand it. A plus b whole square is a square plus b square plus 2ab. So, We'll expand this. Cosecant, let me write it down. Here, a square, that means cosecant square theta plus b square cot square theta plus 2ab cosecant theta cot theta. Again, minus 1 is also there. Next, here, the same, I'll expand it in the numerator part. Cosecant square plus cot square plus 2 cosecant theta cot theta plus 1. Now, look at this. Cosecant square and 1 is there. Cot square and plus 1 is there. So, if you see the third identity, 1 plus cot square equal to cosecant square. I am using this identity because in the equation we have cosecant and cot. So, we have to switch over to the third identity. So, here cosecant square minus 1 is there. So, cosecant square, if 1 is taken to the other side, cot square theta is equal to cosecant square theta minus 1. So, instead of cosecant square theta minus 1, I will replace cot square theta here. Cosecant square minus 1. Substitute cot square theta. Again, one more cot square theta is there. Plus 2 cosecant theta cot theta. Same, we'll see this next part. Here there is no minus, so we'll see the cot square. Cot square 1. That means the original identity. 1 plus cot square is cosecant square. So instead of this cot square and 1, I'll substitute cosecant square theta plus there is one more cosecant square theta plus 2 cosecant theta cot theta. So the equation is simplified here. Now let's take this 2 cot square plus 2 cosecant theta and cot theta. Here both are cosecant square, so 2 cosecant square theta plus 2 cosecant theta cot theta. We'll take the common part. Common here is 2 in both. 2 cot theta. 2 cot theta is common. So there's one more cot theta here and here cosecant theta. I've taken it common. Now here what we can take common? 2 and cosecant theta. 2 cosecant theta common. So there is one more cosecant theta plus cot theta is left over. Here we can clearly see the brackets, that means the multiplication. So we can cancel. 2 we can cancel. This part, cot cosecant we can cancel. The leftover is cot theta and cosecant theta. Cot theta by cosecant theta. But we have in our LHS part only cos square theta. So we'll change this into cosine functions. Cot is cos theta by sin theta divided by cosecant is the reciprocal of sine. So 1 by sin theta. We can cancel the denominators. We find simply cos theta by 1, that is equal to cos theta. So this is our LHS. We have started with RHS, we got the LHS. Thus LHS equals to RHS. Hence proved. So like this we can solve all the problems in the chapter of trigonometry, and in particularly I would like to tell that exercise 11.4 the questions will be asked for 4 marks using the trigonometric identities in our public examination, and more particularly this question is been asked twice in our examination. So all of you revise the chapters regarding the values, regarding the ratios and the trigonometric identities. Get it perfect and solve all the problems. With this, I would like to end up this chapter. In our next class, we will come up with a new concept. Thank you.